Hey guys, welcome to Elevated Systems. I'm your host CJ, and I just spent the past couple days benchmarking this. The Vetroo Lurker v240 all-in-one liquid cooler. What'd you think I was gonna say? I was testing the RTX 3060? I can't get my hands on one of those, just like you can't get your hands on a new graphics card. So no, I'm reviewing a product you can actually buy. So the agenda today, first we'll get this AIO out of the box and take a look at what it comes with and review some of its features and stats. Then I'll get it set up on my test bench and cover some of the installation process. Then we'll run the numbers and see how well this AIO keeps my CPU cool. After we review the data, I should be able to share my thoughts on the price to performance of this cooler and my thoughts on all the good, bad, and anything in between. Okay, let's just jump in and get this thing unboxed. All right, instruction manual. I'm not sure how helpful this will be, but there is one in here. And let's start with the fans. So these look and feel like the fans that come with the Vetroo air cooler that I reviewed a few weeks back, but they do have slightly different specs. These fans are rated with a max RPM of 1800, providing a max airflow of 58.8 cubic feet per minute, but Vetroo doesn't provide static pressure info, which is not good considering they're radiator fans. All right, now this should be all the mounting hardware. This AIO is compatible with all Intel 1150X, the new 1200 and the 2011 sockets, and the AMD AM4 socket. We'll get to this stuff in a bit, but let's unwrap the AIO. Now, this is a typical Asetek cooler, and you've seen one Asetek cooler, you've pretty much seen them all, but there are a few ways the manufacturer can improve the performance. First, of course, is the fans. Stronger fans, higher static pressure can remove more heat from the radiator. And the thicker and denser the fin stack, the more heat you can remove. This is a 120 by 240 by 25 millimeter radiator, but the fin stack is only about 18 or 19 millimeters thick, and the radiator is connected to the pump block by 360 millimeter tubes. Okay, let's take a look at the mounting hardware. Okay, this looks to be the RGB controller. I'll need that so we can see the pretty lights. This is the AM4 AMD mounting hardware. And this is the Intel mounting hardware, and then there are separate mounting screws for the 2011 socket. And then we have our fan splitter, so we can connect both the fans to our CPU header. And these are the screws for mounting the fans and then mounting the radiator to a case. And surprisingly, unlike the V5 air cooler, rather than the 4 corner mounts like this Intel mount, Vetroo went with the 2 clips that connect directly to the standard plastic mounts on the AM4 socket. So I'm just gonna go a little off script here and grab an Intel motherboard so we can compare how the 2 mounting systems work. So I got a 1200 socket motherboard, and I guess I need a 1200 socket CPU to go with that. Okay, so the motherboard's ready to go. Let me set up the pump block to be mounted to that. Yeah, these instructions are about worthless. So to install these mounting brackets to the pump block, it says install Intel angular alignment products after locking screw hole installation angle. That's pretty unintelligible to me, but I guess that's why a lot of people have watch videos like this. You'll need the Intel mounting hardware as pictured here. Begin by inserting the notch side of the Intel mounting brackets into the slots on the side of the pump block. Secure the bracket from the bottom side of the pump block using 2 of the M2 screws. Repeat the process on the opposite side. To attach the mounting plate, you need access to the back side of the motherboard. Remove the backing paper from the double-sided mounting tape. This tape is pretty permanent, so only do this if you do not intend to switch out the cooler in the future. Attach the plate by aligning the 3 socket screws with the 3 holes in the plate and passing the 4 mounting nuts through the 4 holes in the motherboard. Now add a pea-size amount of thermal paste to the top of the CPU IHS and remove the plastic film from the AIO cold plate. Align the pump block over the CPU, lining up the holes in the mounting brackets with the plate threads passing through the motherboard. Using the 35mm long spring tension mounting screws, hold the pump block in place and secure each of the 4 corners in place by hand. Either by hand or using a Phillips head screwdriver, tighten the screws a few turns at a time using a star pattern to ensure even pressure on the CPU socket. These screws will bottom out once they have reached the maximum depth. But that is a pretty secure mount. We still have some spring tension here, so as our thermal paste kind of pumps out and expands, we'll have the nice even pressure down on the socket. And I actually like this mounting system better than what I'm about to show you now. You'll need the AMD mounting hardware as pictured here. Begin by inserting the notch side of the AMD mounting brackets into the slot on the side of the pump block with the bracket pointing up. Secure the bracket from the bottom side of the pump block using 2 of the M2 screws. Repeat the process on the opposite side. Next, pass the threads of the attachment clip up through the bottom of the mounting bracket and loosely secure it in place with the spring tension mounting screw. Repeat the process on the opposite side. Using your preferred method, apply the thermal paste to the CPU IHS, peel the plastic film off the bottom of the AIO cold plate, and center the pump block over the CPU with the mounting clips we just installed, aligned with the plastic mounting tabs on the motherboard. Clip each mounting clip onto the tabs, and while holding the clips in place with one hand, tighten the mounting screws evenly until they bottom out on the threads. And then you just hand tighten it, because what I found was if you tried to use a screwdriver to tighten it down, to snug it up, you're just gonna spin that bracket right off that plastic clip. So hand tight, you kind of screw them both down at the same time, hand tight, seems to do okay, and you got a fairly decent mount. So now I'm gonna plug my pump cable into the pump header on my motherboard. That header will, in almost all motherboards at default, will run that pump at 100%, which is fine for an AIO, unless you're really trying to reduce some pump line, and then you can adjust the curve to that manually. And now, let's connect up all this RGB. To connect the addressable RGB to the provided controller, first locate each 3-pin ARGB cable coming from each of the fans and the pump block. Plug these cables into the 3-pin sockets on the controller labeled 1 through 3. To power the controller, plug the SATA power connector into the SATA power coming from your system power supply. If you have a 3-pin 5-volt ARGB header on your motherboard, you can connect the 3-pin lead from the controller directly to your motherboard. Additionally, there is a 2-pin socket you can connect your case reset switch to, or you can use the mode button. To connect the fans, plug each fan into the provided fan splitter cable and plug that cable into the motherboard CPU fan header. And that's it. We should be good to go. Let me get the peripherals hooked up. All right, I got my peripherals hooked up. Let me just fire this up and we'll go straight into BIOS. All right, I'm in BIOS. First thing I'm gonna do is restore all my defaults. So I make sure I have my stock fan curve in place. Now while we're in BIOS here, let's go ahead and just take a look at some of the RGB functions so that we have a single button and we just hit the button, and I think there's 24 different modes on the RGB. We had a chasing, now there's a pulsing through the different colors. Okay, now we just have our standard rainbow. And now we can go switch through just the static colors. Now some more multicolor chasing. And then our chasing, so we can just leave that on our standard rainbow puke while we do some quick testing. So what I want to do right off the bat, I'm just going to jump in here. All core. Put it in all core, 4.4 gigahertz overclock at core voltage of 1.4. And I think that should do. Let's go right in and just punish this cooler right off the bat, see what it can do. Idle right now, currently it's just at 35 degrees Celsius. And we are operating at 4.4 gigahertz across all cores right now. And I just want to stress our CPU and start this up. We've already jumped up to 84 degrees Celsius, and the current temperature in here right now is 25 Celsius. So as this test is running, I kind of want to demonstrate. I don't know if I have. The one issue I suspected I would have with these fans is you can see that between the fan frame and the fan blades right here, we have a pretty significant gap. And if I just put my hand here, I can feel air blowing onto my hand, which I shouldn't feel air blowing onto my hand because the air is being sucked through the fan blades here and being blown out the bottom. But let me just grab something to demonstrate. You can see that plastic bag I'm holding being blown. There's a pretty good amount of air escaping around the edge of the fan, and that is a loss of static pressure. So instead of all the air these fan blades are capable of blowing through the fins, now we have some being actually reflected back from the radiator back out the top side of the fan. So we don't have all the potential air we could have going through the radiator fins and cooling. Okay, so the stress test has been running for about 17 and a half minutes now. We can see that we did peak. We had a maximum peak on the CPU of 94 degrees. However, we averaged about 87 degrees Celsius during the test. And again, these are worst case scenario. I have a max all core overclocked CPU running a system stress test that is pounding the CPU harder than any typical task you would normally do on your PC. Go ahead and stop this test. Okay, again, that was worst case scenario for this cooler. And it actually didn't do too bad. At an average temp of 61 degrees above ambient, that's only 5 degrees warmer than my Lian Li Galahad 240 running the same test, and is pretty much identical to my Cooler Master MasterLiquid LC240E. Now let's take a look at the actual benchmark results. Also for comparison, I have the results from the Lian Li Galahad 240, the Inwent SR24, and the Cooler Master MasterLiquid LC240E, which is the AIO I'll be focusing on for the comparison, as it's in the same price range. But we'll also get to see how it compares to the more expensive premium coolers. And let's start with Prime 95 using the small FFT preset. Here the Vetroo is pretty much neck and neck with the Cooler Master, with only 0.8 Celsius difference, and you can also see that despite the Vetroo's line being near the end of the screen, it's only 1.8 degrees warmer than the in-wind cooler. Next test is the software X265 encoding of a 4K X264 video file using Handbrake. The transcode took approximately 11 minutes to complete. Here, the Vetroo cooler kept the CPU almost 2 degrees cooler than the Cooler Master. Moving on to the 20-minute loop of Cinebench R20, and here we see one of the best showings for the Vetroo, coming in 3 degrees cooler than the Cooler Master at just 35 degrees above ambient. The most punishing test ran at stock settings was the AIO Extreme test, and here we see the highest temps for the Vetroo with a temp of 48.6 degrees above ambient, but again just 0.6 degrees above the Cooler Master. For this Cinebench run, the CPU was at stock frequency, but the stock AIO fans were set to their max RPM, and here the Vetroo and the Cooler Master were dead even. For the fan normalized test, the stock AIO fans were replaced with a set of Noctua NFP12s set to a constant 1700 RPM, and here the Vetroo actually beats everything, which confirms the static pressure of the stock Vetroo fans is lacking. Finally, looking at the average of all the benchmarks minus the fan normalized run, we see the Vetroo beat out the Cooler Master by 0.7 of a degree Celsius. So conclusions, final thoughts about the Vetroo Lurker v240. First and foremost, I wasn't as impressed with the performance and quality of the Vetroo AIO as I was with the Vetroo V5 air cooler. Now, performance wasn't bad. It's actually right in line with the AIOs in this price point and comparable to most 240 Asetek style AIOs. Now, the points where I think that can be improved are, first, the fans. The fans are solid, they're well built and have good airflow at a relatively low RPM, but the loss of static pressure around the sides of the blades does affect cooling potential of the cooler. The second point is the AMD mounting method. While I have used this type of mounting system on other AIOs like the Lian Li Galahad, that's worked well, the lower quality of the clips and screws here don't work as well. Vetroo should just have included the same types of brackets as with the Intel mounting solution that screws right into the stock AMD backplate, just like they did with the V5 cooler. I actually tried the AMD brackets from the V5, but the screw holes on the pump block didn't line up. Now, in all fairness, if you're just mounting it once and leaving it on, like normal people, it's not too bad, but when unmounting and remounting it several times, it got frustrating. Another nice feature of this whole assembly is all the ARGB cables are standard 3-pin connectors, not some proprietary thing. So if you don't want to use the controller at all and just connect them directly to and control the lighting with your motherboard, all you need is a simple RGB splitter. Okay, final recommendation. Is this AIO worth the price for its performance? Yeah, at $79.99 US or $74.99 currently with the $5 coupon, it performs in line with the slightly more expensive Cooler Master MasterLiquid LC240E, and on average, it cooled within 0.7 of a degree of the Lian Li Galahad 240, which is almost twice the cost. Now, where it does lack is, just like pretty much any 240 AIO in this price point, is the ability to handle higher heat loads and overclocking. So I would say if you're looking for a 240 AIO for a lower budget to mid-range gaming PC or workstation with some good addressable RGB, then this is a good choice. Any questions? Let me know in the comments. I answer pretty much all the questions I get. Don't forget to hit that like on the way out and consider subscribing to the channel. That's it for this one, guys. I hope to catch you in the next one. Until then, stay safe.